better. I feel much better about it. So L prime, 1 plus 4 outside, x squared minus 64. And we have to find the least common denominator, x squared minus 64 minus x squared and the square root of x squared minus 64. Okay. Still ugly, but manageable. So 1 minus x squared minus 64, the square root of x squared minus 64. And here I have 256. And then x squared minus 64 and the square root of x squared minus 64 minus 256 over x squared minus 64, the square root of x squared minus 64. Okay. So I still have to solve this equation somehow. So I have x squared minus 64 to 1/2 plus 1, so that's 3/2 equals 256. And I will first square, and 256 squared and the cube root, because I have to square to get over the denominator, and then I have to take the cube root. So then I have x squared equals 64 plus the cube root of 256 squared, whatever that is. I have no idea. So I'm going to share my screen and then punch it in. So what am I punching in? I'm punching in 64 and then plus 256 to power 2/3. Okay. And I also need the square root of that. $10.21. 10.21. I forgot the measurement unit feet. Yes. And this is x. Don't enter it. Don't enter it. This is just x. We have not determined L. So this is the critical number. I'm using only the positive value. And now I have to go back to L. This is L of x. This is L of x. In this expression, I have to plug in 10.21 because I only found this piece that gives a minimum, but I don't know. I haven't studied the sign yet. I have to show that it's a minimum. But the problem is asking me for L. So that's why I have to plug it in L. So let's do that. I don't like leaving problems in the middle. So I have 4x and divided by the square root of x squared minus 64. You know me, I like to see the function in there. Okay, and then outside plus x, and I plug in 10.21. Calm down with those errors. Okay, so 2 decimal digits, the length of the ladder should be 16.65. So L of 10.21. L of 10.21 is approximately 16.65 feet. I don't know if this gives a minimum or a maximum. I don't trust it before I explain it. 3, 4, 5, page 5. Okay, so where is my derivative? Gee whiz. Here's my derivative. when I plug in 0, let's see what happens when I plug in 0. No, I can't plug in 0 because this is negative. I will not plug in anything in the denominator. This has to be positive anyway. And it is. At 10, it's positive. But I need to plug in, when I plug in 9, no, that's not going to, yeah, this is positive. When I plug in 9, this is positive. This will be negative. Yep. So I am certain now that when x is 10.21, L prime of x is negative and then positive. So this gives a minimum. And this is the minimum ladder. Okay. So it took me 5 pages of calculations. So can you please enter it? And I hope it's correct. Let me know. Okay, good. So next question. Anything else that you would like to work on? So this, I'm going to say we looked at an optimization situation. Next question. Anything else you would like to continue with, or if you have other questions for me? It was a very good question, Quinn. Thank you.
Thank you.
Did you put it in? I hope I don't have it. Did it work?
That's right.
Awesome, awesome. I really didn't want to do it again. Thank you for your help. Good. So what else would you like to work on? So I'm assuming that we know every little thing here. We don't need any explanation, any review.
Can we do MVT?
Yes. So let's do MVT. Perfect. Okay, so I'm looking at MVT. This was in section 4.2. So let's look at the mean value theorem. Okay. So let's say we have a function f of x, 2x squared minus 3x plus 1, and they are giving us 0, 2, and they are asking us to apply the mean value theorem to find c that is guaranteed by MVT. Okay. So in number 1, I have to present the 2 hypotheses of MVT. In number 1, I have to say f of x continuous. It's a polynomial function on closed interval 0, 2. Closed means brackets, as a poly function, which is continuous everywhere. Number 2, f of x is differentiable on the open interval 0, 2 for the same reason. Then I have to say from 1 and 2 by MVT, I will find a C. I will find a C in the open interval 0, 2 such that f prime of C equals f of 2 minus f of 0 over 2 minus 0. First, I'll find f prime of x, which is 4x minus 3. I will replace this with c in here, so I have 4c minus 3 equals 2 minus 0 is 2. I will find f of 2 and I will find f of 0. I know f of 0 is 1. And f of 2 is 8 minus 6 plus 1. 4 times 2 is 8 minus 6 plus 1. So 3. So I'll solve this equation. I'll find c. So 4c minus 3 equals 3 minus 1 is 2. 2 over 2 is 1. I move 3 to the other side. 4c equals 4. C equals 1. This is not sufficient. I have to show that it's included in 0, 2. If I don't write this, you may say, yeah, but it's guaranteed it will be in the interval. Yes, but what if you made an error? You have to show that you checked. Indeed, 1 is a number between 0 and 2. And that's all you have to write for MVT. Any questions on the steps for MVT or any question? Any question here on all these steps? Okay.
Can we do an MVT problem that isn't a polynomial for like how we find like proof that it's
Yes.
different?
Yeah. So can you give me a function? Is there something that you discovered in WebAssign maybe? Or they are using it? Do you have a function? The function has to be continuous and differentiable. So no matter what, otherwise MVT is not applicable. So this piece has to be clear. Whatever function and whatever interval, this has to be true. If these are not true, then MVT is not applicable. Was that the issue, you think?
Yeah, I think I understand.
Yeah. So whatever function, if the function is not continuous on the given interval and is not differentiable on the given interval, all you have to say is, because it's not continuous, let's say on the interval, or it has a cusp, it's not differentiable on that, MVT is not applicable. Done. Do you have another function for us, Quinn? Anything, any function. In class, we looked at that natural log. We had natural log.
Yeah. Oh yeah, I remember that one.
But if you have another function for us from WebAssign or somewhere else, give it to us so we can work on it. Okay, next one. Next question from any of this. Or if you have anything else, of course. So let me ask you this. Can I consider Newton's method done?
Do one more, I guess.
Okay. Do you have one for us?
We could just do, I guess, the second one from WebAssign.
Yes.
Okay.
Yes. Second one from WebAssign. Very good. Where are you, WebAssign? WebAssign is here. WebAssign is here. I guess I have to start from scratch or something. Yeah, okay. So Newton's method, view. And let's look at the second one. Use Newton's method to approximate a given number correct to 8 decimal places. Wow.
No, the one above that one.
Oh, I'm
That's
sorry. Use Newton's method with the specified initial approximation, blah, 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 4 decimal places to solve this. This we can solve by hand, you know that. So we have 2 over x minus x squared plus 1 equals 0. They want us to start with the first iteration as being 2. Fine. And they want us to find, they want us to find x1. No, x1 is given, and they want us to find x3. So they want us to find x2 and x3, and they want us to answer to 4. Okay, fine. Good. So once they're giving us the first iteration, you do not have to use the intermediate value theorem. No need anymore. If we're not given the first iteration, if we're not given the interval, then you have to say that the function is continuous on whatever, and you have to say that f of a is either positive and negative or negative and positive. Therefore, IVT, because it's continuous, guarantees a solution between A and B. But there is no need to do this right now because they're telling us where to start. So all I need to do is create Newton's function, x minus that function over its derivative. So because I have too many negatives in here, when I pull out the negative, all these become positive and this changes into positive. Now I have to be very careful how I enter this in the graphing calculator because I have to have parentheses top and bottom. Very good problem. Let me see the time here. Oh, okay, I'm fine. So very good pick. I really enjoyed this one. Like the first one was very interesting. Okay, so in y equals, clear x plus the numerator 2 divided by x and then minus x squared and then plus 1 and then divide by 2 over x squared and then plus 2x and close. So get out of there, go to variables, y variable. If you missed any of the steps, I have a video posted that I recorded with you in class. So they're asking us to put in 2. Okay, so this is x sub 2, 1.55. They wanted 3 decimal digits. What was it? 4. Yeah. Okay, so 5555. And then second an entry. Then I won the previous answer. Okay, and this is our x sub 3. So x sub 3 is 1.5215 because they only want 4 decimal digits. Very good problem. Good. Any questions on this? Any questions on the steps or anything?